You may know that Newton's sitting in a garden. Suppose here is an apple tree. Suddenly an apple falls. Then Newton thought, the apple that has fallen down, why should it not go upward? After quite a lot of thinking, he came to a conclusion that this earth pulls everything down. Earth attracts this. Earth exerts a downward force on this, and due to this force it falls down. As the force acts, it brings acceleration in that. So we observe an increasing speed in the falling object. A thought comes to our mind that Earth exerts force on any body downward toward its center. As Newton come to a conclusion which is known as Newton's Law of Gravitation. Newton's Law of Gravitation. He said, any two bodies in the universe, any two bodies attracts each other. Suppose these are two mass particles M1, M2. These are two mass particles. They will attract each other. The distance between them is r. So any two bodies having mass will exert force on each other or attract each other. This force is called gravitational force. Got it? He gave a law regarding the factors the gravitational force depend on. So this is gravitational force F. Okay. This law is known as Newton's Law of Gravitation. That force is proportional to product of the masses and inversely proportional to square of distance between them. These two statements are called Newton's Law of Gravitation. If we combine these two, F proportional to M1 M2 upon R square, we get F equals capital G M1 M2 upon R square. Here capital G is proportionality constant, which is called, this G is called universal gravitational constant. Universal gravitational constant. So G is a constant and its value is 6.67 into 10 raised to power minus 11 Newton meter square upon kg square. Its unit can be obtained from this equation. This G is very small, very small. And due to a small value of capital G, this constant, the gravitational force between these two objects will be too small to feel that the fact that M1 M2 very small and the value of G is very small, whatever be the value of R, G being too small, the force come out to be very small and we cannot feel the attractive force between them. The force will be big enough to feel if anybody out of these two will be large, out of M1 and M2. That is, their product will be large. This is possible if one body to be large like Earth, Sun and any heavenly body. Both may be big, its net product will be large. The body around us have a small mass and G being small, so we do not feel the force. Capital G is obtained experimentally. Its value is small, so the force is small. We know gravitational force is a weak force. So this force is called, what this force is called? Gravitational force. I told you that. Now, G is called universal gravitational constant. Why? Why it is called universal? Why universal words is used here? Because its value is same everywhere. Everywhere in universe. In every condition as well. Even if you change the temperature, pressure and anything, the value of G will not change. All things change but G will not change. That's why its name is universal gravitational constant. Secondly, the value of this constant does not depend upon the medium. Hence, putting any two body between two mass particles does not change the force between them. If we put anything between two mass particles, while we know electric force between two charged particles depend upon the medium. So the gravitational force is independent of medium. Okay. Let's repeat everything again. This force does not depend upon medium. Any two bodies attract each other. The force acts along the line joining the two mass particles. It acts along the line joining the two. So this force is called center force. Center force is one which acts along the line joining the two bodies. Electrostatic force is also center force. Remember, gravitational force is directly proportional to product of the masses and inversely proportional to square of distance between them. This equation is center part of this chapter. Center part, very important equation. This will be used everywhere in this chapter where we have to find the force, a gravitational force between two mass body.